all the amazing stuff going on at CERN.
CERN.
Yeah, CERN. Now, I know a lot of you are probably already familiar
Oh, for sure.
with CERN,
Oh, for sure.
but we want to like really get into it, like way deeper than,
Deeper.
just a Wikipedia summary or something like that. So we got a whole bunch of great sources to dive into, and yeah, it's going to be exciting because we're going to be looking at,
Yeah.
like the historical discoveries, the stuff they're doing right now, and
And the future.
and the future.
Possibilities.
Yeah, crazy possibilities. Like did you know that the World Wide Web was born at CERN?
It's true.
Yeah.
Crazy.
It's one of those things that people might think is just like an internet rumor, but it's actually true.
It's totally true. And we're also going to get into, like, they're using AI to potentially uncover hidden dimensions.
Yeah.
Like what?
Mind-blowing.
That's nuts.
Yeah. And we're also going to talk about like the possibility of interstellar particle physics. Like using space itself as a laboratory.
Wow.
So much to get into. Let's start with like just the basics.
Okay.
So what is CERN? Where is it? And like what are they trying to do there?
Okay. So CERN stands for the European Organization for Nuclear Research.
Okay.
And it's located near Geneva, Switzerland. But it's really important to note that it's a truly global effort.
Oh, yeah.
Thousands of scientists from all over the world
Wow.
come together. And at its core, CERN is all about pushing the frontiers of knowledge. They're trying to answer the biggest questions about the universe. What is it made of? How did it begin? And what are the laws of physics that govern everything?
Like the fundamental laws.
Exactly, the fundamental laws.
That's so cool.
Yeah, and I think this is something we can all be excited about, right? Like, these discoveries have a ripple effect on all of us.
Oh, yeah, for sure.
Not just the scientists, They impact our technology, our medicine, and really just our overall understanding of the world.
Yeah, I mean, like, for example, the World Wide Web.
Yeah.
Like we were saying.
There you go.
Was invented at CERN.
Exactly.
That's crazy. Like, I always thought that was like an internet rumor.
Right.
Like,
Yeah.
like the same place where they're smashing atoms also gave us the internet. Like,
yeah.
It just doesn't seem.
It's a bit of a mind-blowing fact.
Yeah, totally.
But it's true. In 1989, there was this British scientist, Tim Berners-Lee, who was working at CERN and needed a way for scientists to easily share information.
Oh, I see.
And so he created the World Wide Web. And yeah, the rest is history.
The rest is history.
Think about how much the web has changed our lives, right?
Oh, yeah.
Like how we communicate.
Totally.
How we learn, how we live our lives. It's incredible.
It really shows you like how these discoveries can have these huge, like unintended consequences.
Unforeseen. Yeah.
Yeah. Yeah. Unforeseen impacts like on society and stuff.
Absolutely.
That's amazing. But that's not the only like big thing that came out of CERN, right?
Yeah, no.
They also discovered the Higgs boson.
Huge.
Which I know was a really big deal.
It was a massive, massive achievement.
Okay.
It was like finding a missing piece of a puzzle.
Okay.
A puzzle that explains how particles get their mass.
Okay.
So for decades, physicists knew something had to be giving particles mass.
Right.
But they just couldn't figure out what it was.
Right.
And in 2012, at CERN, they finally confirmed its existence.
Wow.
Using the Large Hadron Collider.
Okay. So the Large Hadron Collider, help me picture this.
Okay.
Is it basically like a giant...
It's a good way to put it.
Microscope that smashes atoms together?
It's a massive, incredibly powerful machine that smashes atoms together at almost the speed of light.
Wow.
And by doing that, scientists can actually see these tiny building blocks of the universe and how they interact.
So it's like...
It's mind-blowing.
Looking into like the smallest levels of reality.
Exactly. Yeah. The most fundamental level.
Yeah. Wow.
Yeah.
It must take like a huge team to operate something like that.
Oh, yeah.
Right.
Absolutely. I mean, thousands of scientists from around the world collaborated on this project.
Wow.
And it was really a testament to global scientific cooperation.
Yeah.
Like, this was a huge moment for physics, And what's really exciting is they're making it even more powerful.
Oh, really?
Yeah. The high luminosity LHC is going to come online in a few years.
Wow. So it's like they're taking like an already super powered...
That's supercharging it.
Super powered microscope.
Yeah.
And giving it an even bigger boost.
Yeah, exactly.
What will that enable them to do?
So imagine upgrading your computer's processing power by like tenfold.
Okay.
That's kind of what we're talking about here. They'll be able to collect way more data.
I see.
Leading to even more exciting discoveries. It's like opening up this whole new window into the universe.
Oh, and getting an even clearer view
Wow.
of how physics works at this most fundamental level.
So we're talking like new particles, new
Potentially, yeah.
forces. Who knows?
Who knows? That's the exciting part.
Yeah, yeah.
We don't know what we're going to find.
That's so cool.
Exactly.
It's incredible to think about all the potential discoveries that are just like waiting out there to be made.
Absolutely.
And I know CERN isn't just focused on the Large Hadron Collider.
No, not at all.
They're also doing research on things like, antimatter and quantum computing and like stuff that sounds straight out of...
It sounds very sci-fi, doesn't it?
Yeah, totally science fiction.
Yeah, yeah.
But before we get too far down that road, like what stands out to you so far about what we've learned about CERN?
I think for me, it's the sheer scale of everything.
Yeah.
Not just the size of these machines, but also the ambition of these projects.
Yeah, that's huge.
And the potential impact of their discoveries. It's truly mind-boggling. It's mind-boggling. It's like, it's almost hard to...
It's hard to wrap your head around it.
Yeah. It's hard to even fathom like what they're doing.
Absolutely.
It's so big.
And what's really fascinating is that we're just scratching the surface.
Really?
Yeah, the next few decades of research at CERN, they're going to be even more revolutionary, I think.
Wow. Okay.
Yeah.
Well, let's get into it.
Let's do it.
So we were just talking about how CERN's research can feel like science fiction.
Yeah. And speaking of science fiction, you mentioned antimatter.
Yes.
That was one of the things that really caught my attention. It sounds so futuristic.
It does.
But they're actually researching it now.
It's happened.
Like right now.
Yeah.
At CERN. So...
It's wild.
It's wild. What is antimatter?
So antimatter, it's definitely one of the most mind-bending concepts in physics. It's like the opposite of matter.
Okay.
So for every particle of matter... there's a corresponding antiparticle with the opposite charge.
Okay, so it's like a mirror image. Yeah, like a mirror image.
Of the particles that make up everything around us.
Exactly.
Okay. What happens when matter and antimatter come into contact?
That's the cool part. When matter and antimatter meet,
Yeah.
They annihilate each other.
Whoa.
And release a tremendous amount of energy.
What?
Yeah. That's what makes antimatter so intriguing.
It sounds dangerous.
It could be.
But also, like...
very powerful.
Really powerful.
Potentially powerful, yeah. I mean, it sounds like something out of Star Trek, right?
Yeah.
But CERN is actually studying it, like its properties, and trying to figure out why there's so much more matter than antimatter in the universe.
Right.
It's this huge puzzle.
That's great.
In cosmology that we haven't solved yet.
Okay, so we got this antimatter that could potentially unlock, like... huge amounts of energy.
Huge amounts of energy.
Then you got quantum computing,
right?
Which is another area that's like making waves everywhere.
Absolutely.
What is CERN doing with quantum computing?
Yeah. CERN is exploring how quantum computing can be used to like solve really complex problems in particle physics.
Okay.
We're still early days.
Yeah.
But the potential is enormous.
Yeah.
I mean, quantum computers could completely change
how
we analyze data from experiments like the Large Hadron Collider, how we simulate particle interactions, and even how we design new experiments.
So it's like a whole new way.
It's like a whole new toolkit for particle physics.
Yeah. That's so cool. It sounds like CERN is at the forefront of so many like these futuristic technologies that could have a massive impact on the world.
And sometimes the biggest breakthroughs come from unexpected places, right?
Yeah, for sure.
Like, remember, the World Wide Web was born at CERN.
And a need to share.
Out of a practical problem.
Yeah, data.
Exactly.
Yeah. That's wild.
And even their research on particle beams, that has led to advancements in things like medical imaging and cancer treatment.
Yeah, wow.
That's really cool.
Yeah. So they're not just focused on, like, the theoretical stuff.
No, not at all.
They're actually, like...
they have real-world applications.
Making things better.
Absolutely.
For humanity as a whole.
That's the goal.
That's amazing.
Yeah.
So what's next for CERN? Are they just going to keep building bigger and bigger colliders?
It's a good question. There is talk about building an even bigger collider called the Future Circular Collider, or FCC.
FCC?
FCC, yeah.
Right.
And this thing would be massive.
Like, how big are we talking?
Up to 100 kilometers in circumference.
100 kilometers? That's like...
it's hard to even imagine, right?
It's almost like a city-sized...
yeah, a city-sized atom smasher It's crazy.
What would they hope to discover with something that big?
Well, the FCC would let scientists reach even higher energies.
Okay.
Give them an even deeper look into the fundamental structure of the universe.
Okay.
I mean, they could potentially discover new particles.
Wow.
Test theories that go beyond our current understanding, and maybe even gain a better understanding of dark matter and dark energy.
Okay, hold on. Dark matter and dark energy.
Yeah.
I've heard those terms before, but
They're pretty mysterious.
they're kind of like, ick, out there.
Yeah, they are. They're two of the biggest mysteries in astrophysics.
Okay.
I mean, we know they exist because of their gravitational effects on galaxies and the expansion of the universe.
Oh, okay.
But we haven't actually directly observed them.
Really?
Yeah, we can't see dark matter because it doesn't interact with light.
Oh, okay.
And dark energy is even more elusive.
So we don't even know what it is.
We know it's there because it's causing the expansion of the universe to speed up.
What?
Like
So
some kind of invisible force pushing everything apart.
that's mind-blowing.
It's pretty wild, right? It's like we're living in a universe that we barely understand.
Yeah, that's pretty humbling.
It really is.
Okay, so we've got the Large Hadron Collider, we got antimatter, we got dark matter,
You got it all.
dark energy. It's like CERN is pushing the boundaries of what we thought was possible. What are some of the more futuristic, almost unimaginable possibilities that they're researching?
So one really fascinating idea being discussed is interstellar particle physics.
Interstellar particle physics.
Yeah, imagine doing experiments in space,
Whoa.
using the universe as a laboratory.
How would that even work?
So it would involve collaborations with space agencies
Okay.
to deploy detectors in orbit or even on other planets.
Okay.
And this would allow scientists to study high-energy cosmic rays and other things that are really hard to observe
Right.
here on Earth.
Okay, so we're talking like
Yeah,
taking particle physics to like a whole other level,
to a whole new level, yeah.
beyond the confines of our planet.
Exactly, beyond Earth.
That's incredible.
Yeah.
What else is out there? What other like mind-boggling ideas are they working on?
Well, some scientists at CERN are exploring some truly mind-bending concepts,
Like what?
like using quantum entanglement to study the nature of time, or even searching for evidence of extra dimensions.
Extra dimensions.
Extra dimensions.
Okay, now that
Now we're going beyond science fiction
yeah.
into the realm of pure imagination.
Yeah, that's crazy. Can
Yeah.
you give me a little more on extra dimensions? Like,
Yeah, so it's a head spinner, for sure. It's based on the idea that there might be more spatial dimensions
okay,
than the three that we experience.
right, like up, down, left, right,
Yeah, exactly.
forward, backward.
Exactly. Those are our three
Okay,
spatial
I see.
dimensions. But the idea is there might be more.
Okay,
These extra dimensions could be curled up, like tiny, tiny,
okay,
hidden from view at the macroscopic level,
okay.
but detectable at the subatomic scales that CERN is exploring.
So like the Large Hadron Collider might be able to see evidence
Potentially, yeah.
of these extra dimensions.
Yeah, it's pretty wild.
That's crazy.
It's like something out of a movie, but it's real science happening at CERN.
Yeah. It sounds like they're involved in just about every
It seems like,
area of like cutting edge physics research.
yeah, they're really pushing the boundaries.
Is there anything they aren't working on?
Well, they haven't quite cracked warp drive technology yet,
Not yet.
but I wouldn't rule anything out.
Yeah, right.
With CERN, it seems like anything is possible.
Yeah, anything is possible.
Yeah.
It's incredible. Man, we've been on quite a journey today, exploring the mind-blowing research at CERN.
It's been a lot, hasn't it?
Yeah, from smashing atoms to search for extra dimensions, it's been wild.
It really puts into perspective just how far we've come in our understanding of the universe,
Yeah.
but also how much we still don't know, right?
Yeah, and I think that's what makes CERN so exciting, you know?
Yeah.
Like, they're pushing the boundaries of knowledge and making us think about the universe in totally new ways.
It's true. I mean, think about the Higgs boson.
Yeah.
That wasn't just a scientific breakthrough. It was a fundamental shift in our understanding of like what the universe is actually made of.
Yeah, it's like,
At the most basic level.
yeah, like these particles are so tiny, but they make up like literally everything.
They make up everything we see and experience.
That's wild. And then you got like dark matter and dark energy.
Right.
These mysterious forces
And
that,
invisible.
yeah, we don't even really understand them.
We don't even know what they are, really.
But they like make up most of the universe, right?
Most of the universe. It's kind of humbling when you think about it.
Yeah, it really is.
Like, we only understand a tiny fraction
Yeah,
of what's actually out there.
it's crazy. What is it about the work at CERN that you find so captivating?
Well, I think it's that constant reminder that there's still so much more to learn, so many mysteries to uncover.
Yeah.
And it's like a challenge to keep expanding our thinking,
Right.
to consider possibilities that might seem,
Impossible.
yeah, impossible or just strange at first.
Yeah, like extra dimensions. I have to admit, I'm still trying to wrap my head around that one.
I get it. It's a lot to process.
It's a tough concept.
But theoretical physicists have been working on these ideas for decades. And CERN's research could actually provide the experimental evidence to back it all up. Like if we found evidence for extra dimensions, it would fundamentally change how we understand the universe.
That would be like a paradigm shift.
It would be a complete paradigm shift.
That's exciting, but also kind of daunting,
I think ultimately it's a reason for optimism.
Okay.
The more we learn about the universe,
Yeah.
the more we appreciate its beauty and its complexity and just the incredible power of human curiosity.
That's a great way to put it. It's not about being afraid of the unknown, but embracing it.
Exactly.
With a sense of wonder.
With a sense of wonder and excitement.
Yeah. And CERN really embodies that spirit.
Absolutely. It's a testament to our drive to explore,
To discover.
and understand the world around us.
And it's so cool that it brings together the best minds from around the world.
It's a truly global effort.
Yeah. So as we wrap up, what do you think the future holds for CERN?
Well, based on the past, I think we can expect some truly groundbreaking discoveries, mind-boggling theories, and amazing technologies.
Like what kind of technologies?
Who knows? Maybe someday we'll even have answers to some of those big philosophical questions.
About the universe and our place in it?
Exactly. The origin of the universe, the nature of reality, it's all on the table.
Wow. And maybe we'll even get that warp drive you were talking about.
Hey, a physicist can dream, right?
Fair enough. But in all seriousness, CERN is really leading the charge in humanity's quest.
To understand the universe.
Yeah. And it's something anyone can be a part of.
Absolutely. There are so many resources out there, books to read, documentaries to watch.
The information's out there.
If you want to learn more, it's all there.
It doesn't matter if you're a physicist
Yeah,
or just someone curious about the world.
exactly. We can all keep asking questions, stay curious.
And never stop learning.
Because as we've seen with CERN, the more we discover,
Yeah.
the more we realize how much more there is to explore.
The universe is a vast and mysterious place.
And we've only just begun to scratch the surface.
Well, on that note, we'll leave you with one final thought.
Okay.
With all these advancements and the potential for even more incredible discoveries on the horizon, what do you think the future holds?
That's a question for all of us to ponder. Thanks for joining us on this deep dive into CERN.
Keep exploring.